Step-by-step exam solutions. Okay, maths class, training you to excel. Subscribe, give a thumbs up, share with friends, notification so that you will receive the next video. Step-by-step exam solutions. Okay, maths class, step-by-step to exam success. Step number 1, plan. Number 2, pray. Number 3, prepare. Number 4, preview. Number 5, perform. In this presentation, we are going to solve May-June WASSCE 2012 questions number 12 and 13. Question number 12 is on geometry, trigonometric graph. Question number 13 is also on geometry, surface area of shapes. Question number 12. 12a. Copy and complete the table of values for y is equal to 1 minus 4 cos x. 12b. Using a scale of 2 centimeters to 30 degrees on the x-axis and 2 centimeters to 1 unit on the y-axis, draw the graph of y is equal to 1 minus 4 cos x for the values of x from 0 degrees to 300 degrees. C. Use the graph to solve the equation 1 minus 4 cos x is equal to 0. 2. Find the value of y when x is equal to 105 degrees. 3. Find x when y is equal to 1.5. Let's complete the table. The function we are plotting is y is equal to 1 minus 4 cos x. Then we are going to complete the first one when the value of x is 30 degrees. So we are going to use 30 degrees to replace x. So therefore, instead of cos x, we are going to be having cos 30 degrees. Then we use calculator, find the value of cos 30, 0.866, multiply that by 4, that will give us 1 minus 3.464. The 1 minus 3.464 will give us minus 2.464. To one decimal places, that will give us to one decimal place, that will give us minus 2.5. Now when x is 60 degrees, we are going to replace cos x with cos 60 degrees. So that's cos 60. Use calculator, we'll find the value of cos 60. The value of cos 60 is 0.5. On simplification, we have 1 minus 2. So y is equal to minus 1 at this point. Then for the same way, we are going to find y when x is 90 degrees. (120). Then we are going to substitute the value of cos 120. That will give us, on simplification, we'll have y is equal to 3. So we are going to go straight to cos 150, or when x is 150. So cos x will give us cos 150. On using calculator, we can find the value of cos 150, and that is minus 0.866. Multiply that by 4. We are going to get 1 plus 3.464. Add 4.5 to one decimal place. So now we are going to do the same thing for when x is 180 degrees. So we replace cos s with cos 180. Use calculator, we evaluate that cos 180 is equal to minus 1. Multiply that by minus 4, you have plus 4. So y is equal to 5.0 to one decimal place. When x is 240, we simplify that. So y is going to give us 3. So now that we have completed these ones, the last one, following the same way, we are going to find that the value of the last one will be 1. Now that we have completed the table, we'll go straight to the graph board to plot the graph. Here is the graph board. We are going to import the table so that we can be able to use the values of the x and y to plot the graph. So that's the function we are plotting, and this is the scale. So using a scale of 2 centimeters to 30 degrees on the x-axis, that's it. Every 2 centimeters is 30. Every 2 centimeters is 30. In this case, we say the scale is uniform. Then on the y-axis, 2 centimeters is equal to 1 unit. Every 2 centimeters is 1. Every 2 centimeters is 1. Every 2 centimeters is 1. So therefore, the scale for plotting the graph is as given in the question. Then we are now going to start plotting. When x is 0, y is minus 3. So x is 0 here, y is minus 3 here. So you plot the point, you see the point. And when x is 30, y is minus 2.5. 30 minus 2 minus 2.5. That's the point. When x is 60, y is minus 1. This is 60, x is 60 here, and this is minus 1. So you plot at that point. When x is 90, y is 1. X is 90 at this point, y is 1 at this point. You plot at that point. Then 123. So if this is 120, we move straight to 3 and plot the point there. Then 150, 4.5. This is 4. Then this is 4.5 here. Then 185. That's the point there. Then 210, 4.5. The same level with 150. So you plot at this point. Then 240 will be at the same level as 120. So you plot it at this point. Then 270 will be at the same level as 90. You plot at that point here. Then 300 minus 1. 300 minus 1 at this point. Now that we have completed the plotting, we are going to join these points with a smooth curve. Let's do that now. The blue line is the curve. Now we are going to use this curve to answer these questions here. Use your graph to solve this equation. Find the value of y when x is 105 and find the value of s when y is 1.5. Let's start with the first question. Solving this equation is the same as finding the roots of this equation, and this root is where the blue line crosses the x-axis, the red line, and that happened at this point and at this point. So so that's the first point. So now we're going to take the value of that point. That is 75 degrees. 60, 90, halfway. I remember 2 centimeters is 30, so halfway is 15. 15 plus 60 is 75. Then the next point is at this point. We're going to take the reading. That's 285. This is 270. Halfway between 270 and 300 is 15. So you add 15 to this 285. So therefore, question number 1, the roots or the solution of that equation are 75 and 285. Then the next question, find the value of y when s is equal to 105 degrees. So now we're now going to this value 90 plus 15 will give us 105 at this point. So we draw a line to touch the curve at this point, and from this point we draw another line to touch the curve at this point. Then we take the reading of that. So what is the value? You can see clearly is 2. So the same way also we're going to, so therefore the value of y when x is equal to 105 is 2. Then for the last question here, find the value of s when y is equal to 1.5. We'll come to 1.5 and draw our line. That's the line for 1.5. It crossed the curve at this point, also at this point. So we're now going to take the value. That's the first point. Then we'll trace it down. That's it. Then we'll take the value. 97.5 degrees. This 90, each small square is 3, and then this is 3. Halfway is 1.5, 97.5. Then the same thing also we're going to do here. We put the value here and draw a line down and take the value of that line. So that will give us 264 degrees. We take the reading, 264 degrees. So we'll have the values. So therefore, for question number, when y is equal to 1.5, the values of x are 97.5 and 264. That brings us to the end of question number 12. We go straight to question number 13. Question number 13a. In the diagram, PQ is equal to 6 cm, QR is equal to 13 cm, RS is equal to 5 cm, and angle RSQ is a right angle. Calculate correct one decimal place the length PX. Now let's go straight to the solution to 13a. So now that's the diagram with all the dimension given. So now we're going to see how do we solve this. Now if you look at this diagram, this side is given, this side is given, and the angle between them is also given in the question. It's not given directly, but you can find it. So when we have included angle and two sides, we can solve such a problem with cosine rule. So we need cosine rule to solve this question now. So now we now write down the cosine rule. Px squared, the red line now, will be given in terms of these two sides that are still being highlighted. So the first one is SR squared plus PR squared plus minus the product of PR and SR multiplied by 2, and then the cos of the angle between them. So now we're now going to find Px. So now here, SR from here, you can see XR is 5 centimeters being highlighted alone now. So that's, we substitute 5 centimeters squared, and then the next one now is to find PR. PR is the summation of PQ and QR. So if you add them, that will give us 19. That's 19 squared. Then minus, then 2 multiplied by 5 multiplied by 19. That's PR and XR. So now, then the cos of this angle, now we're going to see how to find it. Look at the blue triangle. With this blue triangle, we can find the angle theta, but we don't need to find the whole angle. So how do we define this angle now? This ratio adjacent to this angle, and this is the longest side, the hypotenuse. So therefore, the cos of this angle, cos theta, will be equal to 5. So write 5 at this point, and then this hypotenuse 13, write 13. We don't need to evaluate this because we are going to take it and write it as cos theta here. So we do that. So now that is 5 over 13. Then we need to evaluate this. So that will give me 25 plus square of this 361. Then we multiply the whole of this with 5. Then divide by 5 over 13. Now we have addition, subtraction, multiplication, division. Now we know that BODMAS demand that we should take division, multiplication before addition and subtraction. So now that's what we are going to do here now. So now we are going to multiply this and then divide by this. So now I have 950 over 13. So now we are going to use calculator to divide this so that we can use the value directly. So now we have 386. Now using calculator to divide this, we are going to have 73.08. Now using calculator also we subtract these two quantities, these two numbers. So we have this minus that will give us a 312.92. Now we're going to find PS by finding the square root of both sides. So PS will give us the square root of this. That's the square root of that. And then PS will give us 17.69 centimeters. But we're asked to give our answer to one decimal place. So we're going to do that. That gives us 17.7 centimeters. That's the solution to question number 13A. We're now going to go straight to the next board to solve question number 13B. Now question number 13B. The diagram shows a wooden structure in the form of a cone mounted on a hemispherical base. The vertical height of the cone is 24 centimeters and the base radius is 7 centimeters. Calculate, correct to three significant figures, the surface area of the structure. Take pi as 22/7. Now let's sketch the diagram so that we can be able to solve the question. So that's the diagram. The cone is mounted on a hemispherical base. So this is a hemisphere and this is a cone. These two form together what we call this structure. So now the vertical height of the cone is 24 centimeters and the base radius is 7, and the radius of the hemisphere is also 7 because they have the same it had the same radius as the cone. Now let's how we are going to solve this question together. Now let's try to separate them. If we separate them, that's what we have: cone and a hemisphere. The surface area of a cone is pi RL. The surface area of a hemisphere is 2 pi r squared, since the top is empty. It's not a solid hemisphere. So now therefore surface area of the hemisphere is 2 pi r, while the surface area of the cone is pi r l, as already shown on the diagram. Then for us to be able to find the curved surface area of the cone, we need to find the slant height of the cone. We need to find the slant height of the cone, and that's this side. And that's a right angle triangle. You can see it here. So now that's the right angle triangle. Let's try to bring this triangle out. So now there's the triangle, the height, the slant height, and the radius. So these are related. From Pythagoras rule, we have L squared is equal to H squared plus R squared. So we're going to find the value of the slant height. We substitute the value of 24 squared, then 7 squared. Then we simplify this: 576, and this is 49. You can do these things with your calculator. Add these two values, you have 625, and this is a perfect square. So therefore, taking the square root of this side, I have L. Taking the square root of this side, you are going to have the square root of 625, which we know is going to give us 25 centimeters. So now we know the slant height. We can go ahead to find the curved surface area of this, and also the surface area of the hemisphere. Now let's join them back again. So we have our shape back. Then we're now going to write the formula for the surface area of the cone and the surface area of the hemisphere. So the total surface area will give us the surface area of the cone, that's the curved surface area of the cone, plus the curved surface area of the hemisphere. Then we're now going to substitute our values. The total surface area of that shape, or this shape, will now give us this is the value of pi 22/7 multiplied by the base radius multiplied by the slant height we have calculated here, 25. Then we are going to add it to the surface area of the hemisphere. That's 2 times 22/7 multiplied by 7 squared. Now we are going to simplify this. With calculator we can easily simplify that. Then using calculator to multiply all these numbers we have here, we are going to have the answer as 550 plus. Then using calculator to multiply all these numbers we have here, we are going to have 308. This is a very simple addition, so use calculator again. We add. Adding these two numbers, we are going to have 858 square centimeters, the total surface area of this shape. Thanks for watching. Subscribe and give a thumbs up.